to the next Algebra 2 video. This is continuing our last video on simplifying exponential expressions, just with more complex examples. So I have 3 problems on the board that we're going to discuss and see that sometimes we have to actually apply more than one exponent rule for an individual problem. Sometimes not. So let's take a look, for example, at problem number 1. And before I go ahead and start to solve or simplify any of these things, I want you to try to do it on your own, but also think about which rule you're going to use from our last video. Are you going to use the product rule, quotient rule, zero exponent rule, the negative exponent rule, or the power rule to simplify this first problem? And what I hope you see is that we're going to be using the power rule, right? We have a couple of different things inside of a parentheses, but also we have an exponent outside that parentheses, and that exponent, that power, is what we're going to use to multiply to all of our exponents inside our parentheses. So, how many exponents do we have inside of our parentheses? Well, at first glance, it might look like we have 2, but there's actually 3 exponents. That's because one of them is invisible. Notice that b is the base, and 4 is its exponent, a is the base, and 7 is its exponent, but also 6 is the base of an exponent, and this invisible exponent is 1, right? 6 to the first power is the same thing as 6. The reason that's important to go ahead and make visible whenever you have an invisible exponent is because that 2, we're going to multiply that 2 to all of our different exponents using the power rule. Okay? So we're distributing that 2 basically to all of our different numbers, 1, 7, and 4, by multiplying it to them. For example, we will have 6, and our exponent is now 1 times 2. We've distributed that 2 to the first exponent, a to the 7 times 2 power, and b to the 4 times 2 power. Okay. Simplifying this further, 1 times 2 is just 2, right? 7 times 2 will be exponent of 14 now, and 4 times 2 will be 8. The last thing we have to do here is to make sure that our number is simplified as well as our variables are. So 6 squared is 6 times 6, and that is 36, a to the 14th, b to the 8th power. So this is a little bit different from our last video in that when we're using the power rule, we're not just multiplying 2 to the last exponent inside the parentheses, we're multiplying 2 to all of our exponents inside of the parentheses that it belongs to. So that is important to know. Okay? So that would be our first example of a more complex type of problem. But here, notice we only used one exponent rule. So let's take a look at a problem where we are using more than one exponent rule. And I have one listed here. Okay? What do you think you might do first in this problem? What exponent rule do you think you're going to end up using to simplify this? Okay. And what you should hopefully see, and one of the first things I'm going to recommend that you usually try to get rid of first, is the negative exponents that you have in your problem. We're going to use the negative exponent rule to move the base and negative exponent to the opposite location of wherever it currently starts. So notice that we have x to the power of negative 2 over 7, and that is a fraction, and we can have fractions as exponents, that's allowed. Okay. We're going to move that whole thing into our denominator. It's going to move from the numerator to the denominator, whereas that y to the negative 5/2 power is going to move from our denominator to our numerator. The reason we're doing this is because we want to get rid of that negative exponent, and this is the rule that we can use by which to do that. So, simplifying this a little bit or rewriting our problem, we still have y to the power of 1 over 2. We now have y to the power of 5 over 2. It's moved to the numerator. In our denominator, we have 15. Okay. X to the 5 over 7 stays where it is. And we're going to be now multiplying that by our new base and exponent that has moved, right? That is 2 over 7 now. It's positive. Okay, our fraction moved into the denominator with its base. And simplifying from here, okay, we're not using the negative exponent rule anymore. We've already taken care of that, but there is one more rule that we will have to use, and hopefully you see that's the product rule, right? Currently, we're multiplying both in the numerator and the denominator two different numbers that have the same base. Now, they have different exponents, but because they have the same base, we can do something more to simplify this. Okay? So right now, what that means is we take y, that's our base, and add the exponents together. That's the product rule. Okay. 1/2 plus 5/2, excuse me. And in our denominator, our base is x. And the exponents that we are adding will be 5/7 plus 2/7. Okay. So simplifying. 9/15, by the way, you can reduce that fraction. Both of those numbers, 9 and 15, are divisible by 3. So you could have done this at the very beginning, but if you want to go ahead and do it now, 9 divided by 3 is 3, and 15 divided by 3 is 5. In other words, 9/15 gives you the same decimal as 3/5, right? Because you can divide them both by 3. And simplifying what we have now, 1/2 plus 5/2 is not 6/4, it's 6/2. When we add fractions together, remember we're only adding the numerators, right? 1 plus 5 is 6. We don't add 2 plus 2. Think of how 1/2 plus 1/2 is 1 whole. It's not 2/4, it's 2/2, right? Same thing here, we're only adding our numerators for these fractions. Likewise down here, 5 plus 2 in our numerator is 7. The denominator stays the same. And now we can simplify those exponents, and our final answer here will be 3 times y to the power of 3. 6 divided by 2 is 3. And in our denominator we have 5x to the power of anything divided by itself is 1. So this would be our final simplified answer for our problem here, and that is because we were both able to use the negative exponent rule and the product rule. So that is something that you could expect to see on the test as well. All right, now we are going to take a look at one final problem where we also are combining different rules to simplify. And I want you to go ahead and take a look at this, and once again think about what rules are we going to use and why. So actually in this case there are 3 different rules that we're going to use, and as is often the case in math, you can sometimes solve a problem one way by following a first step, or you can solve it another way by starting with a different step. As long as you use all the steps at the end of the day, it doesn't really matter which one you start with. So for example, okay, some students might want to get rid of their negative exponents first, and that's a common thing. So what we could do would be to take that -4, okay, put a box around that exponent and that base, and move it from our denominator to our numerator. Okay. How that would look would be like this. Right? That -4 has become a +4. And now it's in our numerator. It's switched locations from denominator to numerator. M to the third stays where it is for now. But notice that we still have a negative exponent. So how are we going to get rid of this negative exponent? Well, one thing that we could do is to flip the denominator to the numerator and the numerator to the denominator. That's another way that you can get rid of this negative exponent, because at the end of the day, we are going to have to use the power rule for this, and we're going to have to multiply that -1/2 to all of our exponents, unless we change it to a +1/2 first. So this is what I mean. Okay. We could flip m to the third from the denominator to the numerator, and then flip everything in the numerator to the denominator. Once again, we do this so that now our fraction that we're going to multiply at the end is positive rather than negative. So there won't have to be any more flipping going on later. We've already taken account of our negative exponents. You could have started with something else and worked with negative exponents later, but I find that students typically like to do this first, so it's up to you. Other rules that we're going to have to use, for example, okay, we're going to have to use the product rule. Notice that we have n to the fourth times n to the fourth. Two numbers that have the same base. So what that means is that we're going to need to add those exponents. Right? So doing that, simplifying, we have n to the power of 8. And one more thing that we can do is to use our quotient rule. This is when we divide two numbers that have the same base. So m on top, m on bottom. What we can do here, okay, subtract numerator minus denominator. That's going to give us m3 minus 7. Okay. And 3 minus 7 is going to give you a negative number, which in this case will turn out to be -4. Now, one last thing I'm going to recommend before we start using the power rule, go ahead and get rid of that negative exponent again. Anytime you get a negative exponent, I'm going to just say probably the best idea is to move it from its location to the opposite. So in this case, from numerator to denominator. And that will leave us with a 1 in our numerator and m to the fourth times n to the eighth in our denominator. Again, we're going to raise that to the 1/2 power. How are we going to do that? We're going to distribute 1/2 to every single exponent. So 1/2 times this, and times this. Okay. So 1 to the 1/2 power, right? 1 times 1/2 is just 1/2. 4 times 1/2, okay, that's going to be 2, right? 4 times 1/2 equals 2. And 8 times 1/2, it's the same thing as 8 divided by 2, is going to be 4. Now, we're going to talk about this a little bit more next class. What happens if we end up with a fraction, right? What happens if we end up with an exponent that's a fraction? That's going to be talked about more next class, but what you can know is that 1 to any power, 1 times itself, any number of times, or in this case, the two things that are going to multiply to give 1, it's always just 1. Okay? 1 times 1 times 1 times 1 is always 1, and to get anything times itself to equal 1, it will have to be 1 times 1. So in this case, look forward to next class when we actually start to understand what does this mean. It's actually going to mean the square root. So the square root of 1 here will be 1. We're going to talk about it in the next video, though. The point here is that you can solve different problems different ways as long as you're aware of all of the different rules that you'll need to apply to each problem. So in this case, we first use the negative exponent rule. Okay. Then we use the negative exponent rule again to flip our fraction upside down. Then we used the product rule. Then we used the quotient rule, so m to the third over m to the seventh. Quotient rule, we subtract instead of adding those exponents. We use the negative exponent rule one more time. And lastly we use the power rule. We distributed 1/2 to all of our exponents and see what we got. If you type 1 to the 1/2 power in the calculator, by the way, it will give you a 1. So I know that's a bit of a longer problem. That is one of the more difficult ones for this unit. But if you are able to do that, then you do know all your exponent rules very well, and that is the goal. So that's why I wanted to give one that was a little bit more challenging. Hopefully you found it beneficial, and in the next video we will talk about what happens when you have fractions for exponents, what does that mean, and we're going to relate that to radicals, and that's our next topic for our